Hello, in this video in Chapter 5 for MAC2233, Calculus for Business and Social Sciences, we're going to look at some more finding extrema. The next two are going to be a little more on the difficult side, but we'll go through them. So we're trying to find the extrema for the function where t is raised to the 2/3 on the interval from -1 to 1. So to find the stationary points, we take the derivative, set it equal to 0. Well, the derivative, the 2/3 would go in front. 2/3 minus 1 would be -1/3. Now I can rewrite 2/3 t to the -1/3 as 2 over 3 t to the 1/3. Negative goes to the denominator and becomes positive. And you notice that this doesn't work. There's not a number that we would plug in that would make it 0, so there are no stationary points. And again, if we try to cross multiply here to solve like a proportion, 0 times the variable is gone, so there's nothing to solve for, so this doesn't work, so there's no stationary points. For singular, we look at the derivative and see what number would make this undefined. So here, notice that the variable's in the denominator, so if I made t in this case 0, t to the 1/3 is 0, 0 times 3 is 0, then that would make it undefined. So we have 0 as a singular, possible singular point. And then endpoints come from the domain, -1 to 1. So we have three possible extrema at 0, -1, and 1. We plug them here, 0, -1, and 1. And remember to find the y value, plug them into the original t to the 1/3. So if we go to the calculator, go to y equals x raised parenthesis 2/3. And then if we want to use the table feature, make sure your table is set up by hitting second window. Make sure the independent is on ask and the dependent is on auto. Go to second graph for the table, and if I plug in -1, I get 1. If I plug in 1, you get 1, and 0 will give you 0. Okay, so 0, 0 is from the singular point, -1, 1 is an endpoint, 1, 1 is an endpoint. Now we're going to graph this. In order to graph this, we need to understand the window. So the window is going to be from -1 to 1, because that was given in our domain. And then for the y value, the lowest we need is 0 and the highest is 1. So I'm going to go from -2 to 2. So I go to the calculator, window, -1 to 1. And then our scale will be by ones. And then our y value minimum would be -2, y max to +2, counting by ones, hit graph. Remember, we're graphing the original. And you'll notice that it produces like that V-shaped, that sharp corner. So when we look at this, 0, 0 would be an absolute min, because to the left is higher, to the right is higher. And it's the lowest point in the graph. -1, 1 and 1, 1 are both the highest. They're both maxes, because to the right is lower, and the other one to the left is lower. So they're both maxes, and they're both the highest. So we have two absolute maxes. Okay, in the next example, a little bit harder, we're trying to find the extrema of the function x plus 1 over x. So again, we go through our steps. To find the stationary, we take the derivative, set equal to 0. The derivative of x, or 1x, is 1. 1 over x can be written as x to the -1. So you take the derivative, the -1 goes in front, subtract 1, -1 minus 1 is -2. So we have 1 minus 1 x to the -2 set equal to 0. So what we can do is the -2 would go to the denominator, and we have 1 minus 1 over x squared equals 0. But to solve this, we can make a proportion. We can do that by adding 1 over x squared to both sides, which gives us 1 over x squared equals 1. And like a proportion, 1 over x squared equals 1 over 1. To solve, we cross multiply. X squared times 1 is x squared. 1 times 1 is 1, so x squared equals 1, therefore x is plus or minus 1. For singular points, we look at the derivative, 1 minus 1 over x squared. What number can make this undefined? The answer is 0. And then endpoints, there's none given, so the three places I'm going to look are 0, -1, and 1. So 0, -1, and 1. And remember, we plug into the original, so I go to my calculator, go to y equals, clear the old one. I'm going to have x plus parentheses 1 divided by x, close parenthesis. And again, the numbers we're going to plug in when I go to the table by hitting second graph are -1, which gives us -2, 1, which gives us 2, and 0 gives us an error. So remember, these are possible extrema, therefore 0 is not going to be 1. And so -1, -2 came from stationary, 1, 2 came from stationary, and then the 0 error means that's not going to be an extrema. And when we graph it, they didn't give us the domain or range, so therefore we look at the numbers. -1 is the furthest, so we'll go maybe to -3. 1 is the furthest on the x, maybe we'll go to +3. And then on that y-axis is -2 and 2, so maybe go to -3 and 3, or even -4 and 4. So I go to my calculator, I hit window, -3, x minimum, x max 3, x scale 1, and then y minimum, let's say -4, y max +4, counting by ones, graph. And again, 0, 0, there's no graph there, it's undefined, it's not going to be an extrema, but we can see our points, -1, -2, and 1, 2. We can also hit second trace, number 1 for value, type in -1, and it will show us the -1, -2. Notice to the left and to the right are lower, therefore that's a max, but all these points are higher, so that would be a relative max. If I type in 1, that shows us 1, 2. To the left is higher, to the right is higher, therefore it's a minimum, but all these points are lower, so it'll be a relative min. So for this problem, -1, -2 is a relative max, 1, 2 is a relative min. Okay? Then we're going to look at some word problems in the next video.